Hey folks, today we're going to talk about electrolytes and the nature of solutions. Do the second worksheet. This is your worksheet number 2. Okay. Distinguish between an electrolyte and a non-electrolyte. Right. Well, let's start there. An electrolyte is something that dissolves into ions. So, for example, when I have NaCl and I put it in water, it breaks apart into sodium ion plus chlorine ion. Right, and these are both aqueous. All right. Whereas this over here was a solid. All right, when we first start out, we dump it in water. Okay, once you have these ions in water, these ions will conduct electricity, and as a result, this is an electrolyte. Right, a non-electrolyte would be something like C6H12O6, and while that dissolves in water, it still remains as C6H12O6 in water. All right, okay, so it's dissolved. You can't see it, but it did not break down into ions. So the ions are what are required to make an electrolyte. This is not an ion, so as a result, it's not an electrolyte. Now, there are some things that are weak electrolytes. So, for example, we will have acetic acid, C2H3O2, all right, and that breaks up into H plus ions and C2H3O2 ions, but it doesn't fully dissociate. Meaning some break up and some don't, okay? And because only a few break up, it is a weak electrolyte. So that's an example of a weak electrolyte, okay? This sodium chloride is an example of a strong electrolyte, and sugar is an example of a non-electrolyte. Identify the solvent and solutes in vinegar. All right, well, that's really easy. If you look at acetic acid, I'm sorry, if you look at vinegar, it says 5% acidity. All right, so that means 95% is water. Right, and if you look at the label, you'll see that it's mainly water. So the solvent is water. The thing that is being dissolved is the solute. Remember, when you are looking at something, how do you determine the solute? It either changes state. When, for example, salt will change state, or it's the one that you have less of if they are in the same state. Okay, so the solvent is the water, and the acid is the solute. Write a chemical equation showing how calcium chloride dissolves in water. Well, calcium chloride is CaCl2, because calcium is 2+, chlorine is 1-, and it's a solid. And it dissolves into calcium, which has a 2+ charge, and that's aqueous because it's dissolved in water, and chlorine, but there are 2 of them, and each one has a 1- charge, and they are also aqueous. They've dissolved in water. Okay, so that's really the way you'd write it. Bottom line is you need to indicate that these are aqueous and that they have a charge. Okay, and that's what makes them ions, and that's what makes them wonderful conductors of electricity. So that is an electrolyte. All right, what's the basis for distinguishing between solutions, colloids, and suspensions? Well, I think I'm answering the next question too, by the way, while I'm at this. So a solution is something, for example, salt water. It looks like one thing, it's clear. All right? An example might be Dr. Pepper, Coca-Cola, something where you look at something and you say the caffeine that is in Dr. Pepper or Coke and the phosphoric acid that's in there and all that, they're going to stay in there forever, and you're not going to be able to see them. In other words, they don't settle out. Okay, and if you shine a light through it, the light goes straight through it. Okay, so that's an example of something that's a solution, right? But when you have a colloid is something you can shine the light through, but it's going to disperse the light. So you're actually going to see stuff. And I showed you this in the podcast, where you can actually see stuff in there. Now that means the particles are very small. These particles are extremely small, but colloids, they're bigger. All right, and let's go to suspensions, and that'll kind of help. Suspensions are things like milk, for example, would be a good example. Muddy water would be an example, and these things settle out over time. All right, so if I left a cup of muddy water sitting there, over time the mud is all going to go to the bottom, and this will be water. All right, another thing you can do is filter it. All right, you can filter it and you can get the dirt out, and the water will go through the filter. These are examples of something that is a suspension, okay, because the particles are bigger. Now, colloids, the particles tend to be smaller, so as a result, they do not settle out. And something where you might have, where you could look at would be glue, where those particles aren't going to settle over time. You can leave Elmer's glue sitting on a shelf for 2 years, and it's not going to settle. All right, so that's an example of a colloid. Right. We talked about the Tyndall effect in the podcast. You might want to look at that as well. The colloids are, with the Tyndall effect, you can actually see the light going through them, whereas when you have a solution, the water goes right through and it doesn't stop the light from going through. Okay. Examples. So let's go back. Examples here would be salt water. Right. An example here would be glue of a colloid. A suspension would be something that settles out. For example, muddy water would be an example. All right. Hot chocolate would be another example. So, okay. What's the difference between a hygroscopic compound and a deliquescent compound? Well, actually, a deliquescent compound is a hygroscopic compound. A hygroscopic compound absorbs water. Okay, so a lot of the compounds that we use, a lot of our ionic compounds absorb water. I think one of them is copper sulfate. All right, and it absorbs water, so it becomes a hydrate. And I honestly don't remember which hydrate it is. I don't know if it absorbs. I think it's 5 waters, but I'm not 100% sure. But I think it absorbs 5 waters. Right, but it's still a solid. All right, a deliquescent compound is something like sodium hydroxide. Right. Now what's going to happen here is it's going to absorb so much water that it's going to start to dissolve in the water that it pulls in. Right. Another example of a hygroscopic compound is silica gel. All right. It's something that you see when you buy a pair of shoes, for example. There's a little packet of silica gel in there, and I talked about that in the podcast as well. Right. These are things that absorb water, but they don't get wet. They don't look wet. All right. A deliquescent compound is going to actually get wet to the point where it dissolves. All right, that's it for this. We'll see you in class. If you have any questions, please let us know. We'll be happy to help. Take care. Bye.